We're going to look now at how geologists will depict the Earth's surface in like map form. This is SP crater. It stands for shitpot crater, and it is a volcano cinder cone that is 70,000 or less years old. It's near Flagstaff, Arizona. So here's the crater. Let's look at an image. So this is kind of a artist's rendition. Here's SP crater and the lava flow coming out the top. So let's go back to the picture. Here's those two lobes coming off the lava flow. Back to the image. So you can keep an eye on SP craters. We go through these images. So this is kind of a colored artist rendition of the landscape. So here are two other ones. On the left is a computer generated shaded relief map. So the relief steep sides are darkened and light's coming from one side, not another. And so we see the topography because of that shaded relief. SP crater is here in it's the really nicely formed volcano here. These are all the the Franciscan volcano field near Flagstaff. I already said that. Okay, on the right is maybe a map you've seen before. This is a topographic map, and on the topographic map, those squiggly lines are connecting points of equal elevation. So here is SP crater, right here. Lines of equal elevation, and the elevation is measured above sea level. So if you get on one of those lines and you walk along that line, you're not going to go up or down. If you jump to another line, you are going to change elevation. That change in elevation from one line to another is called the contour interval. So that is a topographic map. We usually use that topographic base to put data on top of. Okay, speaking of data, here is a satellite image. So in the satellite image, here's SP crater. Here's the flow of the magma lava that flowed up to the north. The different colors on here are showing vegetation, mostly in this image. On the right is the geologic map. And a geologic map is going to have on it what we call formations. Let me move this. The formations are lava flow, scoria cones, cinders, and older flows and limestone. Those four colors depicted on the map are the four mappable rock units. So they were able to find a continuous section and put it on the map. Also on the map are going to be structural features. A structural feature are these faults. So faults cutting across the map. So those are ways we show our geologic data. When we look at topography, we look at, here on the left, underwater is the depth of the water. We would also call a depth of the water a sounding, and the topography of this of a seafloor or the lake there would be the bathymetry. Elevations then, so 0, if this is sea level, 0 would be the coastline, and then above that are the elevations above sea level. Once you're away from sea level, if you have a topographic high, here's a ridge and a valley, the difference between the valley floor and the ridge is the relief. So how much relief is from here up to here? Okay. Relief, elevations, depth, or bathymetry. We also can look at the slope of a slope, and so we would call that it would be whatever it is off of the horizontal. So this is a 26-degree slope here. All right. In 3 dimensions, we use block diagrams, and we also do cuts through the rock and call those cross sections. So in this image, we have a valley here, and we've interpreted the geology. So to the front side is the cross section. So we have this older unit on the bottom. That pattern represents an igneous rock, the kind of, and then above that, the next pattern, this orange with the white circles, represents a conglomerate. Above that, these blocks are what we use to represent a limestone, and above that, this would be a sandstone. So those are the units. If we're looking at the side view, an igneous rock, we'll call it a granite, a conglomerate, a limestone, and a sandstone. If we were to just want to show those units and their age relationship, we would make a stratigraphic section. So this is a strat column or stratigraphic section just showing the age relationship between the different units. We can also represent the change in the landscape. So earlier we looked at a landscape like we would see in Monument Valley and how it changed over time. So this is the same thing. Here we have same units here, that granite, a conglomerate, and a limestone, and this blue represents water. The water in that basin then is, there's deposits of sand. So over time then we have a deposit with the granite, the conglomerate, the limestone, and sandstone. And then again over time that would erode and we have a valley in the limestone. So let's go back. That's what we're seeing here. This valley that over time is being cut down into the rock units.